teleportation is real? Does it occur in our everyday lives? Going to school, travelling across the world, or even just stepping outside the house?
Nah, that's just something you see on that Trek Wars Star Trek thing, you know?
We're right in saying that it doesn't occur in our everyday lives. However, quantum teleportation is real.
Ha! You're lying.
In order to understand quantum teleportation, we first have to understand quantum superposition and quantum entanglement. These are some of the most bizarre, strange, mind-boggling theories in the universe. Even Einstein was confused by them, and the words Einstein and confused don't usually come in the same sentence. Superposition is a theory in physics which states that the same particle or electron can have different properties at the same time, meaning it can be in different places or can be spinning in different directions at the same time. This may sound absurd, as how can one thing be in two places? Well, the quantum world is very different, much more different than our world. You can never say where the particle is or what kind of properties it has until you measure it. By measuring it, you force it to give you a result, such as a position. The particle is forced into a position. The fidget spinner in this video is sort of like an electron, in which no colour is pointing towards the direction of the arrow until you measure it, forcing it to give you a result. In this case, orange. The theory of quantum entanglement was first founded by Einstein with the help of two colleagues. Basically what they found is that according to quantum mechanics math, two particles far away from each other can be connected. Einstein called this spooky action at a distance. To represent this, we'll say if a particle is spinning clockwise, it's up, and if it's spinning anti-clockwise, it's down. We have two particles, one in London and one in California. We measured the one in California, and according to superposition, it has around a 50-50 chance of either being up or down. The one in California shows to be up, however this makes the one in London down. This seemed like magic, because if these two particles are entangled, and you measure this particle, the consequence is that the exact opposite happens to this particle. Using the previously discussed concepts of quantum entanglement and quantum superposition, scientists have been able to teleport calcium atoms and photons onto satellites in space. The math and physics of this is extremely complicated, but in basic terms, we have particle A and B entangled by interaction with each other. We bring the particle we want to teleport, C, and entangle it to A. The relations of the entanglement of particles A and C are studied, and this information telling you about particle A is then sent to B. However, particles A and C break down as they have been measured and therefore they have been changed. The information sent to particle B is implemented. So far we've only been able to teleport single atoms, but in the future maybe we can teleport chemical compounds, small objects, and maybe even humans.